Okay, here's 6.2, the natural base e. E is a very famous number in mathematics, kind of like pi. So it has a value that's about 2.718. It comes from this little formula. So as x approaches infinity, this whole value is going to be closer and closer to my 2.718 number. And this is just approximately 2.718. That decimal goes on. But so, if you plug in a really large number in for x, you'll see you'll get something pretty close to 2.718. So let's see what would happen if we plugged in 999 for x here. So I'll start with the fraction 1 over 999. And I'm going to add 1 to that, and this is the contents of my parentheses, and I'm going to be raising that to the 999th end. Okay, and I got about 2.717. It's not quite there, but if I put in an even bigger number, if I added in a fourth 9, then it'd be closer to this, and even closer to the larger numbers I'm putting in. Okay. E is also programmed into graphing calculators. So if you look on my calculator, I've got A, B, C, D, written in green, D, E, F, G, and so forth. That's just if I want to write text. So you'd hit the alpha key if you want that. But I don't want to use this E here. I want to use the lowercase e, which is above the division symbol. So if I hit second and then divide, I don't know if you can see that little E there, but second and divide, an E will show up on my screen. If I hit enter, there's the decimal version that's programmed into the calculator. You'll also want to be raising E to different values a lot. So if you look at there's an LN button near the bottom left here, and if you hit second LN, then you get E raised to something, and then you can put in whatever you want as your exponent. So if you wanted E to the second, there you go. Okay. All right. So I'll get to a use for E in just a minute, but I'm going to review a little bit with some interest problems here. Okay, so Ed invests $100 at 5% interest for 8 years. So my initial amount is the $100. The final amount is Y. I don't know that yet, but I'm going to plug 100 in for the initial amount. Okay. Then I need my rate, which is the 5%. But we want to write that as a decimal, so that would be 0.05. So I'm going to have 1 plus 0.05, so I'll just add that as we go. Okay, and then this is going to be my time. Okay, this was the initial amount was A. Okay, so all right. There's my equation. Now I want to simplify this with my calculator. Make sure you do the exponent before the multiplication, right? So you want to take 1.05 and raise it to the 8th first. Otherwise, you wouldn't be following PEMDAS and you're going to get the wrong answer. So then final thing, multiply by 100. And this is money, so I'm going to round to the nearest cent. So I've got roughly $147.75. Okay. All right. So that's when we're compounding once per year. So that's annual interest. It means that you're adding in the 5% of the $100 into the account once per year. But you could add it more often than that. And that's where this fancier version of the formula is going to come in. So if we're compounding quarterly, that n is going to be the number of compounds per year. So that means n would be 4. You could use this formula on the first problem. Just your n's would be 1. And then you get r over 1, which is just r, and 1 times t, which is just t, right? So it would simplify to this if the n's were both 1. But here, both of the n's are 4s. So our initial amount is still 100. The rate is still 5%, but now that's going to be that numerator, and it's going to be over 4. And I've got another n up there, 4, and we're still leaving an n for 8 years. Okay? So I'm going to pull out my calculator again here. And I'm going to start with the fraction, 0.05 divided by 4. I'll add 1 to that. Okay, and then I'm going to do the exponent, so I'm going to raise this to the 32nd. 4 times 8 is 32, right? And then last thing is to multiply by 100. And I should get more money if I'm adding the 5% in 4 times per year. So let's see if that happens. I did get more money. It's not tons more, but it's a little bit more. So I've got $148.81. Okay, and the more you compound, the more money you'll have. Okay, so if you compounded daily, we'd have more than $148.81, and you could do it every second. And you get more and more, but these jumps are going to get smaller and smaller. You won't make that much more. It's just a little bit more by compounding monthly as opposed to quarterly. And then just a little bit more compounding weekly and so forth. And so those jumps, if you compound more and more, are going to get slower and slower, and these totals are going to be approaching a certain number. And that number they're approaching, you can actually compound continuously. So that means n would be infinity. You'd always be adding the 5% in as you go, okay? Which you might think that you'd be infinitely rich if you did that, but it doesn't quite work like that, okay? So here's a formula. Sometimes you'll see this written, by the way, as y equals PE to the RT, and that's the same thing. It doesn't matter. P is for principal, which means the starting amount. I just use an A for my initial amount, but they're the same thing, okay? And this features E, so that's that 2.718 number, okay? So we still are starting with $100. We've got E. The rate is 5%. And then the time is going to be 8 years, okay? So don't write in 2.718 because you want to use your calculator. It has a much longer version, decimal version of 2.718 in there. And the more of that you use, the better your answer will be. Okay, so I'm going to simplify the exponent here first. Okay? Now, it's tempting to take 100e and raise that to the 0.4th, but you don't want to do that because 100 is actually raised to the first power. We want to do this exponent first. So I want to do e raised to the 0.4 and then multiply that by 100. Okay, so I'm going to hit second and then this ln button down here because it says e to the x. And now I've got e, and I'll raise that to the 0.4. Okay. So just to show my work a little bit here as I go. Okay, and then I'll multiply that by 100. And now I've got $149.18. Which, hey, that's better than the $148.81, but it's a little disappointing, right? You're not infinitely rich. But you do get more the more you compound. Okay. Okay, on to the next page here then. So let's do a little bit of work using e. Remember, e is just going to be a variable, so it's going to behave like any other variable. Okay. So when we've got e to the something times e to the something else, here's the little rule. If you have x squared times x to the third, well, really, you just got 5x's all multiplied together, right? So the key there is that you are going to add the exponents when you're multiplying with the same base. And so the same deal works here. I've got e to the 7 times 3, or plus 3, sorry. I'd have 10 e's all multiplied together. So e to the 10th. Okay. So it's not really clear here if they just want e to the 10th. I think that is what the book is going to be going for, but you could also get a decimal version of that. E to the 10th would be about, let's see, 2200, 26. I'll go to the nearest hundredth here, so 0.47. Okay, there we go. All right, so let's try it over here. And yeah, you could just figure out what e to the 57th is and then figure out what e to the 20th is and multiply them together. But let's combine these. That's going to be e to the 77th. And then we can put that in a calculator again. E to the 77th is going to be 2.76 roughly. Oh, it's not 2.76. I had myself confused. I was like, why is that so low? All right, I've got this E33 thing here, which means we're in scientific notation, right? So this means times 10 to the 33rd, okay? So this is a very large number. So I tell my students if it shows up in scientific notation on your calculator, then you can just put the answer that way. But this means that decimal is going to be moved 33 spots to the right. So it's going to be a very large number, okay? All right, next up, I've got 27e to the 8th over 9e to the 6th. Well, you can kind of just break this into little parts. I kind of like to think of it like that. 27 divided by 9 is going to be 3. Okay, and then when you've got e to the 8th over e to the 6th, if you think about canceling e's, all 6 e's on the bottom would get canceled, and 6 of them on the top would get canceled, and then you'd be left with 2 e's on the top. So just a little exponent rule. If you have x to the 5th over x to the 2nd, that's going to equal x to the 3rd. So you can do this, right? So we can do the same thing here. So I'm going to have e to the 2nd. All right. And then we could, of course, do the decimal version of that. But take e and raise it to the 2nd first. Whoops, I put 0.2 there. E raised to the 2nd. And then multiply by 3 last. So that's going to give me about 22.17. Okay. All right, so let's try it again here. So I'm going to think of it like so. Just break it apart. Hey, 36 divided by 4 is 9. And then for the e's, 10 minus 3 would be 7. There we go. Okay. And decimal version of that, let's see. E raised to the 7th times 9. Always doing the exponent first, then the multiplication. I'm going to the nearest hundredth on all of these. It doesn't say where to round, but okay. All right, and then moving on. When I've got something like this is really what's in the parentheses times itself, right? When it's raised to the 2nd power. When you've only got one term inside of the parentheses, you can distribute the exponent. If I had a binomial or a trinomial, I wouldn't want to do that, but I can do this. So I can raise the 4 to the 2nd, and I can raise the e to the negative 5x to the 2nd, like so. So this is going to be equivalent, because if you did 4e to the negative 5x times itself, well, you would have 2 4's that you're multiplying together, right? And you would have 2e to the negative 5x's that you're multiplying together, okay? So, hey, 4 to the 2nd is 16, okay? When you've got an exponent raised to an exponent, let's do a little review here. When you have this, you'd have 3 groups of x squared. So you'd have x squared 3 times. That means there would be 6 x's all multiplied together. So when you have an exponent raised to another exponent, you can multiply the 2 exponents together. Okay? So this is going to be e raised to the negative 10x. Okay? So I got it down to that, but I don't want to leave a negative exponent in my final answer. So there's another rule you need to know. If you have x raised to the negative 3rd, that equals 1 over x to the 3rd. Okay? So I'm going to take this part and write it as 1 over e to the 10x. Okay? It could be that some teachers would want you to leave it like this, but typically you wouldn't leave a negative exponent in a final answer. Okay? And then when I multiply this together, remember this is 16 over 1, right? So when I multiply together, I'm going to get 16 over e to the 10x. Okay, now this one I can't really simplify further because I don't know what x equals. So I can only simplify it in terms of x. Okay, so that's as far as I can go. All right. All right, so let's try it again here. So I'm going to distribute the 3 to both parts. So I've got 5 to the 3rd, and I've got e to the negative 4x to the 3rd, like that. Okay, so 5 to the 3rd is 125, and then I've got e to the negative 12x. Okay, so when I simplify this part, it's going to become 1 over e to the 12x. Okay, and then that's going to become 125 over e to the 12x. Again, I can't really simplify further because I don't know what x equals. Okay. Okay, So let's take a look at graphing some equations that feature e to the x. All right. So these are both going to be exponential functions because I've got a variable as my exponent. Okay. So these are both going to have what's called a horizontal asymptote. All right, and in both of these, the horizontal asymptote is going to be it's going to be the x-axis on both of these. So what that means is that's the floor of my curve here. Okay. The reason I know that this is going to be the x-axis is because there's nothing added or subtracted to the end of the function. So sometimes you'll have a horizontal asymptote that might be at 5, at y equals 5. But you'd have to have a plus 5 at the end of your graph, or if you had a minus 8 or something, then it would look like that. But these just have a plus 0 at the end. So both of these, my horizontal asymptote is going to be on the x-axis. Okay, and an asymptote is a line that my curve is going to approach and get really close to, but never cross. Okay, so I should get a curve that's going kind of uphill here. I know that's going to happen because this is my base is positive. Okay, so let's try out. Let's find the y-intercept. Okay, so if I want the y-intercept, I'm going to plug in 0 for x, just like I would on any equation here. Okay, so let's see. I'm going to do this. And then e to the 0th equals 1. Anything to the 0th power equals 1. So that means my y-intercept is going to be 3. Okay? And I know it's going to be going uphill, so I could actually make a pretty decent graph just from that. But you could also just find some other points. Okay? So if you're making an xy table here, we just plugged in 0 for x and we found that y was 3. Well, let's see what happens if we plug in 1 for x. Y equals 3e to the first, and when I do this, I'm going to need my calculator for this. I'm going to do that first, right? E to the first. E to the first is 2.718, and then I'm going to multiply that by 3, and I got 8.15 roughly. Okay, so 8.15, something like that. And now I'm getting a pretty good idea what my curve's going to look like. Okay, let's try plugging in a -1. So I'm going to do that on my calculator, e to the -first, and then multiply that by 3, and I got about 1.1. Okay, so at -1, 1.1. Okay, and then I can see what my graph is looking like from there. Okay, so and honestly, in my classes, as long as you know where the asymptote is and you know the y-intercept and you know which way it's going uphill here, then I'm okay with that. But you could always get more points if you want a more accurate graph. Okay, so let's try it out over here. Let's find the y-intercept. I'm going to plug in 0 for x, okay? And remember to do this first. We're not raising the -4 to the 0th. We're only raising e to the 0th. So I've got -4 times 1, and that means -4. So xy table, why not? Let's make one. We got 1 point. We plugged in 0 for x. We got -4 for y. Okay. Let's see what happens when we plug in 1. Okay, so I've got, here, let me put this over here so got that on screen still. All right, let's take e to the first. Whoops. I forgot to hit the second number there. All right, there's e to the first, and then I'm going to multiply that by -4, and I've got -10.87. Okay, so it's going to be a little bit off the bottom of the screen here. 1, -10.8. Okay, let's try -1. So e to the -first. And when you hit the negative, make sure you use this negative button, not the minus. Your calculator will get confused. We're not subtracting anything. I'm just using that negative in parentheses there. Okay, so e to the negative first, multiply that by -4, and I've got negative 1.47. -1, negative 1.47, somewhere in there. Okay, and I got a pretty good idea. Hey, it's going to be going downhill, and it's also going to be approaching that asymptote. So it's going to go something like this. Okay, the farther you get to the left here, the closer and closer your curve will get to the asymptote. Same thing over here. It'll get closer and closer, but it'll never quite touch the asymptote. Okay, so the y-intercept in equations in this format is just going to be that coefficient, right? And then if you got a positive coefficient, it's going to go uphill. If you got a negative coefficient, it's going to go downhill. Okay. All right. That's it for today, and I will see you next time.